సరిపోలే ప్లేస్ సరిపోలే ప్లేస్ సరిపోలే లైన్ చేసుకున్నాం.
So our subject is thermodynamics. What is the generalized equation of work? Closed system work. Generalized equation of closed system work. Become త్వరగా. So yesterday you were present now. Huh? You have to see the notes. So in the class ఏం జరిగింది ఆప్షన్ అంటే వదిలేయడం కాదమ్మా. You should not leave it. ఆప్షన్ అయినా కదా ఇంపార్టెంట్ క్వశ్చన్ ఎగ్జామ్కి వచ్చింది, కోల్ ఇండియాకి వచ్చింది. Generalized equation of work. Based on that you got a question. You cannot tell absent, sir I am absent. You have to answer that question. If you want to select to that company, you have to answer that question. Simply you cannot tell sir I am absent, sir I will not answer. Then you have to lose the job. Central government job. Next. Generalized equation of closed system work. Huh? Generalized, I want the equation of a closed system. Generalized equation of work for a closed system. Please listen the question. Generalized equation of work for a closed system. I want the equation of work for a closed system. For a closed system. I want the generalized equation of work for a closed system. You only come print in the run. Sit here. Idhar randi. So I have given you the generalized equation of work for a closed system is integration of pressure into change in the volume. This is the generalized equation of work for a closed system. So you have to remember this equation. W is equal to integration of PdV. So how to show on the PV diagram? Same thing, how to show on PV diagram means pressure versus volume diagram. We have to plot pressure versus volume diagram. Pressure, how the pressure is varying with respect to the volume. So I have to represent certain system, certain closed system which is undergoing a process. If it is undergoing a process, so how much are work done by the system? It may be anything. If I take compression work 1 to 2, how can you tell this is the compression work means? So volume is decreasing, pressure is increasing. See, the pressure is increasing. If you see the plot here, the plot represents the pressure is increasing, the volume is decreasing. The pressure is increasing and the volume is decreasing. This represents, if you take a closed system, so as we are talking about a closed system is a system where no mass will be transferred out of the system, but energy will be transferred. A closed system is a system where certain unit of mass, certain amount of mass will be present for the closed system. This is my closed system. I am taking gas. If I am taking this is my closed system. If I am taking this gas as my system, it has some boundary. This is the imaginary boundary. So this is, now let us take the initial pressure of this gas is P1. Let us take 1 bar. Initial pressure of this gas is, let us take 1 bar. Understood? No? So let us take the initial pressure of this gas is 1 bar. And the initial volume is, let us take 1 meter cube. 1 meter cube of water. The system is a closed system and there is no mass transfer from the system to the surrounding, there is no mass transfer. There is no mass transfer from the system to the surrounding, from the surrounding to the system. There is no mass transfer. Then the system is called closed system. But energy may be transferred from the system to the surrounding work in the form of work. From the surrounding to the system in the form of heat. Q represent heat, W represent work done. So it is in kilojoules of heat. It is also in kilojoules of heat. Okay. So, but energy can be transferred in the form of heat and work, but mass cannot be transferred. This is called closed system. This is the example of closed system, and this is the example of closed system. So, I am taking a gas. This is a gas, and it is called a closed system. If the initial pressure of the gas is 1 bar, initial volume of the gas is 1 meter cube. Now, I am compressing it. I am doing work on the system. I am doing work on the system. And the system has been compressed to certain volume and certain pressure. And the system has been compressed to certain volume and certain pressure. Now measure the volume. Now measure the volume. The volume has been changed to, let's see the volume. Previously the volume was 1. Now the volume has been changed to 0.5 meter cube. Example now. I am thinking that now if I measure this volume, it is 0.5 meter cube, less than 1. And the volume has been changed. By seeing the diagram physically, you can explain that sir, the volume has been changed. Because of compression, definitely the pressure will be changing. The pressure, let us say the pressure has been changed to 2 bar. Now, if you are compressing the air or if you are compressing the gas, definitely the pressure will be increasing. Definitely the pressure will increase. So how much increase in pressure? I will take it as a 2 bar. I will measure the pressure and I came to know that the pressure is 2 bar. I measured the volume was 0.5 meter cube. Understood now? Work has been done on the system. Work has been done on the system and the system pressure has been increased and the volume has been decreased. How to show on this diagram? How to show on PV diagram? So, draw a PV diagram, pressure versus volume plot. So, as we are compressing it, the pressure should decrease and the volume should decrease. So, in that, I can take any process. This process may be constant volume process. It may be constant volume process, but it is not constant volume process. By seeing the diagram, the volume has been decreased. It is not a constant volume process. One more process. First process. Let us check the first process. It is constant volume process. No, sir. We cannot tell it is a constant volume process because the volume is changing. The volume is changing. So this process cannot be constant volume process. Next, let us see the pressure. Is the process is constant pressure process? No, pressure is also varying. So we can neglect two. So we can tell it is not a constant volume process, it is not a constant pressure process. It may be isothermal process. Yes, it may be isothermal process, constant temperature process. It may be adiabatic process. Adiabatic process. So adiabatic process can be represented by PV port gamma is equal to constant. This is the equation of adiabatic process. I can represent polytropic process. This is fourth process. I can do the work in any of the four processes. In that, these two processes cannot be done. So this process may be any process in these three. In that polytropic process. Polytropic process. Polytropic process. PV port NA is equal to constant. Fifth process. In these five processes, the process may be anything, but by seeing the physically, I can tell that it is not a constant volume process, it is not a constant pressure process. By seeing the diagram, I can tell because the volume is changing, the pressure is changing. So we can neglect these two. Only temperature. So I did not measure temperature. If I am measuring the temperature, and I came to know that after measuring the temperature of this gas, after compression also, if the temperature is constant, a state has been changed from 1 to 2. A state has been changed from one state to second state. This state 2. State 1, state 2. We have compressed it, we are doing work on the piston. It is a closed system. And I came to know that the temperature is constant. After measurement, After measuring, I came to know that the temperature of the gas is constant. Previously, the temperature was 20 degrees. After compression, also the temperature was 20 degrees. Then this process is called constant temperature process. If I am maintaining the temperature constant, I am saying that the temperature of the gas remains constant. Then this process is called constant temperature process. Okay, if the temperature remains constant. Okay, again, if my observation, after my observation, I came to know that there is no heat transfer from the system to the surrounding. After my observation, I came to know that kilojoules of heat. After my observation, I came to know that there is no transfer of heat from the system to the surrounding, from the surrounding to the system. After my observation, after doing work, I came to know that, sir, there is no heat transfer from the surrounding to the system or from the surrounding, from the system to the surrounding. But, and I came to know that Q1 is equal to Q2. No heat has been transferred. Previously, what is the amount of heat present inside the system? After compression, also same amount of heat is present. Means it represents that there is no transfer of heat to the system, from the system to the surrounding, from the surrounding to the system. So this process is called adiabatic process. Understood now? Either it may be isothermal process, either it may be adiabatic process. But both at that time it cannot be. Either one process, we have to represent by one process. But temperature has been changed, but heat transfer is not changing. There is no heat transfer from the system to the surrounding, from the surrounding to the system. Then that process is called adiabatic process. Then the system, closed system has undergone adiabatic process. This closed system, it is example of closed system. This closed system has undergone adiabatic process. Okay? It may be isothermal process, it may be adiabatic process. But both at the time it cannot be. I cannot tell this is both, sir. It is adiabatic process and polytropic process. It may be any process. It may be sitting, you are sitting position or standing position. Either, but you cannot tell I am sitting and standing. You cannot tell like that, no. So you cannot tell that, sir, I am sitting and standing. You have to tell, sir, I am sitting or I am standing. Like that, you can tell the process may be isothermal process or adiabatic process. Anything, one process. If the temperature is maintained constant, it is called isothermal process. Even if the temperature is changing, it cannot be called an isothermal process. But the heat transfer is constant. There is no heat transfer from the system to the surrounding. Then this process is called isothermal process. If you, how can you maintain that, sir? How can you tell the heat is not transferring? I will insulate it. There is a method of insulation like thermocol. I have put a thermocol around the closed system. I will insulate it. This is the method of insulation. This represents we have insulated the system. This represents we have insulated the system. Means there is no heat transfer from the system to the surrounding or from the surrounding to the system. There is no heat transfer from the surrounding to the system and from the system to the surrounding. Then the process is called adiabatic process. Understood now? Okay? The temperature may be or may not be changing. That depends on the process. Temperature, what about temperature, sir? Temperature may be changing, cannot be changing. It may be constant or it may be changing. Okay? But this process is called adiabatic process. How you came to know that it is adiabatic process? Because of there is no heat transfer, sir. There is no heat transfer from the system to the surrounding, from the surrounding to the system. Okay? Understand this? So the process may be, it is a closed system. This closed system may undergo constant volume process, constant pressure process, isothermal process, adiabatic process, and the last process is polytropic process. How can you tell this is a polytropic process? Means if the value of n, the value of n is greater than 1 and it should be less than gamma. What is the gamma value? Depends on the property. 1.4 for 8. Don't tell 1.4 for all the substance. Gamma is equal to 1.4 only for air. For air only 1.4. For nitrogen it will be different. For nitrogen it will be different. For oxygen it will be different. For all the other substances it will be different. But for air gamma value is 1.4. For water gamma value will be different. So don't tell 1.4 is fixed. 1.4 is the value of gamma for 8. If you are taking 8 is my substance. If I am taking 8 is my substance by the flow system, 8 is my system, then the gamma value will be 1.4. Okay? So I am taking 8 because 8 is an ideal gas. So why you are taking 8? Why can't you take other gases? Helium, neon, nitrogen, all these gases. Because 8 is an ideal gas. Easily I can understand air nature. Air is an ideal gas. How can you tell ideal gas means? Because we are inhaling it and we are exhaling it. We are inhaling the air and we are exhaling the air. So air is not doing anything into our body. Air is not doing anything to our body. As we are inhaling the air is not damaging our lungs. Air is not damaging our heart system. It is helping our body. So if it is not reacting with the other substance, that substance is called ideal gas. If any gas, if it is not reacting with other substance, then it is called ideal gas. Gandhiji is an ideal person because he will not react with anybody. If somebody comes and scold him also, he will not react. Then we are telling that Gandhiji is an ideal person for me, sir. So he will not react for all the things. So that we have kept him as a father of the nation. Because with his ahimsa, we got the independence. With his ahimsa, we got the independence, and we are considering him as an ideal person because he will not react for anything. Any person, if we come and beat him, means he will not react. He is an ideal person. So in the same way, air is also ideal gas. Why we are considering air as ideal gas means it will not react with anything. It will not react with any other substance. If you are putting air here, it will not react with the walls of the cylinder. It will not react with the walls of the piston. It will not react with the fellow molecules. The air molecules will not react with the fellow molecules. So air is considered as an ideal gas. What is the equation of ideal gas? We have given equation for ideal gas as PV is equal to MRT. PV is equal to MRT. This is the equation of ideal gas. We have studied in intermediate and your lower classes. What is the equation of ideal gas? PV is equal to MRT. Sir, how can you tell this is the equation of ideal gas? It is the derived. Because ideal gas will not react, so we can give the equation for that. He is a good person. So if a person is an ideal person, we can tell about him. We can tell the characteristics of him. So he is a good person. He will not react with anybody. If somebody comes and scold him also, he will not do anything. We can define him easily because he is an ideal person. If that person is not ideal person, he is quarreling with everybody. Sir, I cannot define him, sir. His nature will be changing from time to time. Understood? No. His nature will be changing from time to time, sir. He will be fighting with other person. He will be reacting with other person. If something, any problem has come, he will come and he will go and react with that person. He will come and scold that person. కొట్లాడుతా అంటారు సార్ అతనితో పక్కన వాళ్ళతో కొట్లాడతారు సార్ వాంతో పెట్టుకొని తలకాయ నొప్పి సార్ అంతే కదమ్మా కొట్లాడే వాంతో రియాక్టింగ్ పర్సన్తో మనం డిఫైన్ చేయలేము ఇప్పుడు ఎలా ఉంటారో చెప్పలేము ఎలా అబ్బాయిని డిఫైన్ చేయమంటే మనం ఏం చెప్తామమ్మా డిఫైన్ అబౌట్ దట్ క్వాలింగ్ పర్సన్ అంటే ఐ కెనాట్ డిఫైన్ హిమ్ సార్ వెరీ డిఫికల్ట్ టు డిఫైన్ హిమ్ ఎప్పుడు ఏ టైంలో ఎలా ఉంటారో మనం చెప్పలేము సో ఐ కెనాట్ గివ్ ద ఈక్వేషన్ ఫర్ నాన్ ఐడియల్ గ్యాసెస్ రియల్ గ్యాసెస్కి ఐ కెనాట్ గివ్ ఈక్వేషన్ బట్ ఐఎమ్ ట్రయింగ్ టు గివ్ ఈక్వేషన్ ఫర్ దట్ ఇంకా రీసెర్చ్ ఫర్ జరుగుతూనే ఉందమ్మా ఒక్కొక్కసారి ఒక్కొక్క ఈక్వేషన్ వచ్చేస్తారు బట్ ఐడియల్ గ్యాస్కి ఈక్వేషన్ ఫిక్స్డ్ బట్ ఫర్ ఐడియల్ గ్యాస్ ద ఈక్వేషన్ is fixed because we can define the equation of ideal gas. We can define the equation of ideal gas, but we cannot define the equation of real gases. Real gases which react with other substance. Real gases are that gases which react with other substance. So ideal gases are that gases which don't react with other substance. So in that air is the ideal gas. So equation of ideal gas is pressure into volume is equal to mass of the substance, universal gas constant into temperature. This is the equation given by our scientists, the equation of ideal gas. So remember the equation. Okay. Now, if I am taking the ideal gas inside, I want to study about the ideal gas and it is a closed system. How much amount of work is done by the system means I have to give the equation, generalize the equation of work. for a closed system. Generalized equation of work for a closed system is integration of pressure into change in the volume. How the pressure is varying with respect to the volume. Then that much amount of work is done by the system, or that much amount of work is done on the system. So this is the, we are doing work on the system. So compression work is, we have to give work on the system. Definitely the pressure and volume will change. So I can represent it like this. I can use the equation. This equation is eligible only for closed system. This equation is eligible only for closed system. Okay? Not for open system. So forget about open system up to 10 classes. Forget about open system up to 10 classes. Just remember, we are dealing with only closed system. What is the equation of work for a closed system? Generalized equation of work. Generalized equation of work for a closed system. Integration of pressure into change in the volume. PdV. How to represent a PV diagram? So how to show this? So in that also, constant volume process, constant pressure process, constant temperature process, adiabatic process, polytropic process. We have 5 different processes. So in that, which process is applicable, we can define it. In that, which process is applicable based on the properties. So if 5 processes, A process follow a system, tell me the pressure. So pressure is varying. So it is not constant pressure process. Tell me about the volume. So volume is also varying. So it is not a volume process. Tell me about the temperature. So temperature is varying. Then it is not a constant temperature process. Sir, tell me about the heat transfer. Is there any heat transfer from the system to the surrounding or from the surrounding to the system? No, sir, there is no heat transfer. Then that process is called adiabatic process. Then I can define this system which has undergone a process. The closed system has undergone a process, and I can tell it as a adiabatic process. How? Because there is no heat transfer from the system to the surrounding, from the surrounding to the system. Are you able to understand it? So it is called an adiabatic process. No, sir. The temperature is remaining constant. After my observation, we have did some work on this closed system, and the pressure is volume has been changed, but temperature is not varying. The temperature remains constant, sir. After your compression also, after doing work on the system also, the temperature is remaining constant. Previously, the temperature is 20 degrees Celsius. Now the temperature is also 20 degrees Celsius. Means the temperature is constant. Then the process is called constant temperature process. Then I can define the system has undergone a process from state 1 to state 2, and it is constant temperature process. Understood or not? Now, sir, heat is transferring and also temperature is also varying. Temperature is varying, so it is not a constant temperature process. Heat is also transferring from the system to the surrounding, from the surrounding to the system. So it is not adiabatic process. It may be polytropic process. Last process, it may be polytropic process. How can you tell that polytropic process means? This, your value of n will be 1.3. It is a polytropic process. The value of n is 1.35. The gas value, polytropic index value, if I after measuring the polytropic index value, if I got the value as 1.35, it is less than gamma and greater than 1, A for A. If I take in other gases, so it is called polytropic process. If the value is 1.4, 1.38, it is also called a polytropic process. The system, then the system is undergoing polytropic process. That value should be less than gamma and greater than 1. If you are measuring the value of n and you came to know that n value is greater than, less than gamma and greater than 1, then I can tell this process is polytropic process. The process may be any process. It may be constant volume process, it may be constant pressure process, constant temperature process, adiabatic process, polytropic process. In that 5 process, the system may undergo a process, any process. What is the generalized equation of work means? This is the work. Apply this one and find out the work. If it is negative, work is done on the gas. If it is a positive, work is done by the gas. Okay, based on the value of gamma PdV. Based on this value, if the value you are getting is positive value, the value you are getting is positive value, it is positive work. Work is done by the system. If the value of work you are getting negative, the value of work you are getting negative, then the work is done on the system. Everybody understood now? So it is a generalized equation of work for a closed system. Again I am telling 10 times I will tell you. Okay, because I know the nature of students. After entering into the second unit, you will forget about closed system. So directly you will take, if it is an open system, some students will write this equation and they will try to solve the problem. They will not see the system, which type of system. So before answering a question, see that is it a closed system or open system. If it is a closed system, write down the equation and solve the problem. If it is an open system, I will give you the next class. Coming classes, after 10 classes, I will introduce the open system. What is open system? What is the generalized equation of open system? I will give that equation. After that classes, you can understand difference between closed and open system. Understood or not? You understood? Now write down conditions for applying the equation. Very, very important. Whatever we have discussed in the thermodynamics, very important topic for a closed system. If you get problems on closed system, you have to be ready to answering that. Definitely one question will be coming for whole India. Thermodynamics, one question will be closed system question. If you are getting questions from thermodynamics, one question will be from closed system question, one question will be from open system question, one question will be from second law of thermodynamics, one question will be from cycle. What are the 5 units we have discussed? Definitely 5 to 10 questions you will get for that examination. Okay? Whatever company you have selected today, suppose Coal India Limited, the GATE examination, they are selecting from GATE examination. They are selecting the students from GATE examination. In that GATE examination, we have thermodynamics as a subject. In that subject, definitely they will ask one question from the closed system. That question will be objective or problematic, applications oriented question, or just the theory question. It may be theory question. What is the generalized equation of work for a closed system? A. Integration of PDV. B. Integration of VDP. C. Integration of TDP. D. Integration of PDT. Understood now? The question may be, the question can be framed like this. What is the generalized equation of work? If the question is like that, if the generalized, find out answer from the following questions. What is the generalized equation of work for closed system? Now this question, very basic question in thermodynamics. This question cannot be answered in GATE, but can be answered in other subjects, other examinations, like assistant executive engineers, assistant engineers, like polytechnic lecturers, degree college, if assistant professors. If you want to select for assistant professor in a university, for that examination they may ask this type of question will be asked. For the GATE, these type of questions will be very simple. Everybody will answer. Those who are preparing for GATE, this type of questions everybody will answer. So one of the simplest question is, what is the generalized equation of work for a closed system? First is option 1, option A. If I take A, option A, integration of TDP, temperature is changing the pressure. You will confuse me, Amma. He will be confusing you based on the options. B, integration of, let us take PDP, pressure changing the temperature. C, integration of PDP. D, integration of PDP. Anything can be asked. These are the objective questions. Definitely they will ask you in examination, if it is a concrete examination. So if you are familiar with the work done for a closed system, what is the generalized equation of work done for a closed system? Sir has given W is equal to integration of PDV. How we got it? We have selected a closed system and the pressure is being applied on the system. The piston will be changing based on the distance travelled, pressure into change in the volume. That is the equation of, generalized equation of work for a closed system. So PDP work. See the options. Option A, integration of TDP. No sir. Pressure with change in the volume.
must switch off.